Today we will talk about Ramsey Cass Koopmans model. Let's talk about the difference Ramsey Cass Koopmans model has with Solow model. RCK model or Ramsey Cass Koopmans model is different from Solow model due to some assumptions. The first difference is the RCK model talks about economic aggregates and their dynamics which are determined at micro level. For example, the consumption is determined within the model at very micro level. The RCK model explains the behavior of this variable consumption at a very micro level. The second difference is, although this model assumes growth of labor and knowledge as given as N and G, but change in capital stock is determined by behavior of household and firms, which maximizes their lifetime utility and profit respectively. So in the second difference of Ramsey Cass Koopmans model from the Solow model is the change in capital stock is determined by the behavior of households and firms, while the households maximize their lifetime utility and the firms maximize their profits. The third difference is the saving rate, which was exogenous in Solow model, is no longer exogenous in RCK model, rather it is endogenous. The model explains the saving rate. The fourth difference is no depreciation of capital is assumed in RCK model. Let's talk about the assumptions. RCK model assumes some assumptions about the firms and households. Starting from firms, the firms are identical. There are large number of firms in an economy. The firms hire worker, they give wages to the worker. The firms hire capital and gives rent on the capital, and the firm hire wages. The firm hire worker and capital from a very competitive market. Firms follow some production function, and this production function is same as the Solow model used, that is y is a function of capital and effective labor. The other fourth assumption about the firms is that firms maximizes their profits, and fifth is household owned firms. All these firms in the economy are owned by households. Actually, the firm's profit is the household's income in RCK model. As we see in the real world, that the firms are owned by households and the profits of the firms are the income of households. Firms takes A as given, growing exogenously at G. The growth rate of technology is exogenous and is constant at the rate of G. Now moving towards the assumptions of RCK model about the households. The first assumption is there are large number of households in the economy. The household size grows at the rate of N. So this is another exogenous growth rate of the households, which is assumed N here. The household supplies all the capital owned to the firms, and in response firms pay the rent. As I talked about it earlier, that the firms in the economy are owned by the households, and households get all the rents and profits from the firms. K0 is aggregate of all the capital. that all the household own in an economy. So all the capital in the economy that is owned by the household is denoted by K0, which is aggregate of all the capital. Then we have K0 by H. This is simply a ratio of all the capital in the economy by the number of the households. So this ratio is actually the average capital owned by per household. RCK model, unlike Solow model, assumes no depreciation of capital. This is an assumption which is distinction from Solow model. Household maximize their lifetime utility, not an utility of a fixed time, but their lifetime utility. To maximize the lifetime utility, household divide income from all sources into consumption and saving. All the income that household receives from different sources, like supplying the labor, like supply of the capital on which they earn rent, the aggregate of this income is divided by the household into consumption and saving. So the sources of income for households are three, that is wages from supply of labor, rent from supply of capital, and profits that household earns from firms. So these are the three sources of income for household. Household utility function takes the form. Utility is a function of time starting from 0 to infinity, e raised to power negative discount rate into utility of consumption, LT by HT. I will explain this in detail. In this function, the CT is the household consumption at time t. At time t, the household has consumption level, that is CT. U function, utility function, is an instantaneous utility function. I will share the details later. LT is the total population of the economy. All the individuals, their number is the population, which is L at time t. And LT by H is how the total population divided by the number of all the households in the economy, and this ratio is actually the average household size in the economy. UCT LT by H is therefore household instantaneous utility, which I will talk later. Rho is the discount rate. Here interesting point is that rho is the discount rate, and if the discount rate is higher, that means lower is the interest rate on the saving, which is the future consumption. So higher is the rho, the value of the rho is the discount rate value. If the discount rate is higher, that means lower is the value of future consumption, and that means lower is the interest rate. The interest rate is low if the discount rate is higher, and that eventually leads to lower saving today. So this is something worth sharing about the discount rate. The instantaneous utility function takes the form utility function of consumption is equal to CT raised to the power of 1 minus theta divided by 1 minus theta, while theta is positive. Let me explain theta, what theta means here. There are few possible explanations. One is theta is the rate of change in marginal utility, or theta is coefficient of relative risk aversion. If the person is risk averser, the value of theta will be high. Theta is the second derivative of utility with respect to change in consumption. Theta is actually independent of C. That means change in consumption does not affect theta. If we take the derivative of utility is a function of consumption, that is equal to ct1 minus theta divided by 1 minus theta, we will get the first derivative of utility function that will be equal to 1 divided by consumption raised to the power theta. So let's put the value of theta is equal to 1. We can guess that the relationship between consumption and utility will be negative. So the change in utility due to change in consumption has a negative relationship. If we change the value of theta from 1 to 2, we will see that still the relationship is negative, but the effect is more rapid or sharp. So we have some features of instantaneous utility function. That is, the first feature is if theta is high, household will not change current and future consumption. As I told you, theta is the coefficient of risk aversion. If risk aversive behavior is very high, that is the value of theta, household will not change their current and future consumption. But if theta is small, that is the risk aversive behavior is small, household will change their current and future consumption. The second feature is if we take limit that theta approaches to 1, our instantaneous utility function will become log of consumption. The third feature is very interesting and has very interesting implications also. That is, the discount rate minus the growth rate of labor minus 1 minus theta into the growth rate of technological progress is greater than 0. This assumption leads to rho, that is the discount rate, is greater than n plus 1 minus theta into g. And the implication of this assumption is discount rate, if it is higher than sum of population growth rate and g, the discount rate is higher than the sum of population growth rate and g. And due to this third assumption about the instantaneous utility function, the household maximization of utility finds solutions, and if this assumption does not hold, the household utility maximization problem will not find any solution. Now let's talk about the maximizing behavior of the firms and household. Starting from the firms. The firms produce output, firms use input, that is labor and capital, and then firms pay labor and capital their marginal product. So while producing the output, the input is labor and capital, and the firm uses this input to produce the output, and the share of labor and capital in the output is being paid by the firms as their margin product. So the labor gets its margin product and the capital gets its margin product as their share in the output. And the firm earns zero profit, and zero profit means normal profit, because economy is competitive and production function is constant return to scale. That's why the firm earns normal profit. Now let's talk about the share of capital and share of labor in the output. As we talked earlier that they get their marginal product. So let's derive the share of capital. We have the production function enabling us that the output is a function of capital and effective labor. So if we take the first derivative with respect to capital, we will get the first derivative of k as the share of capital. So this is the same as in the Solow model. As we assume no depreciation, the returns on the capital is simply the derivative of the function kt. Let's talk about the labor share, how the labor will get its marginal product from the output. The firm pays the marginal product, and the production function is the same. That output is a function of capital and effective labor. So we differentiate this function, that output is function of K and AL with respect to labor. We differentiate the output function with respect to L just to get the marginal output, the marginal share of labor. Y is function of K and AL, or the intensive form is Y is function of small k, the Y is also small. We can rewrite Y as capital Y or AL, that is output per effective labor, and that output per effective labor is function of capital A over L, that is the function of capital per effective labor. So output is the function of capital, output per worker is the function of capital per worker in AL form, that is effective labor. So we can rewrite it like this, and then we take the derivative with respect to labor, because we are interested in the margin product of labor. So for taking the derivative, we are using the simple product rule and then the quotient rule. To use the product rule, we will treat AL as U and K by AL as V, and then after applying the product rule, we have AL F dash of K, and then into the derivative of K by AL. So for the derivative of K by AL, we have to use the quotient rule, and then after replacing K by AL with this small k, we can rewrite the equation as A into F of K minus K F dash of K. So this is the net change in output due to labor, that is the marginal product of the labor, and we can say this is the wages, real wages, that is the income earned by the labor. So we can apply both, we can divide both sides by A to obtain effective wages. Now let's talk about the budget constraint of the households. The household will face a budget constraint, and the budget constraint is that their income should be greater than their consumption, or in our case the income is actually the sum of wages plus the wealth, the initial wealth. Wages are present value of the lifetime labor income, and wealth is the initial wealth. As discussed earlier, consumption is the present value of lifetime consumption. So all throughout his lifetime, the individual will consume, and that consumption is the consumption in this model. The household budget constraint will finally look like this, that the integration of time 0 to infinity e raised to power negative r, this is the discount rate that a household will face into the consumption of a household, into LT by H, that is the average household individuals, is less than K at 0, that is the initial capital per household. So this is the initial wealth of household, plus the integration of time 0 to infinity e raised to power negative r, that is the discount rate that is being faced by this constraint, and this will be the wages WT into the labor supply by household. Let me explain that this part is the discounted lifetime consumption, which should be less than this part, which is discounted lifetime resources. So if you see the left side of less than or equal to sign is the consumption, that is less than or equal to the right side of the sign, which is the resources. So consumption should be less than resources. This is the budget constraint that is being faced by the households. Note that this discount rate of utility function and constraint are different. So this one and this one are different. Household uses a subjective discount rate that is based on their personal preferences for the risk, but the discount rate in the budget constraint is set by the market and it is objectively set. So this is not subjective. We mean that the market will decide what discount rate will the constraint facing, but this is very different from the household discount rate that is based on their subjective preference of risk aversion. So the discount rate set by the market is simply R. This is R, the function of t. So the market rate of interest is possibly change. It may change over the time. So RT, the market set discount rate, is the function of time. So we can write it like this. So this is our budget constraint, and we can write it as the difference of income and consumption should be greater than 0, or 0 should be less than this difference. This means that the difference is greater than 0 and positive. So the household budget constraint says that the difference between income and consumption should be greater than or equal to 0. And the implication of this will be the lifetime consumption should be greater than the initial wealth plus lifetime income. We can combine the two integrals, so wages minus consumption and the rest as it is, and we can say that the difference will be greater than 0 or equal to 0. So when time is starting from 0 to infinity, we can apply limit here, assuming that s is something that approaches to infinity, and we assume t is equal to s. So time is now s, and s approaches to infinity. When s approaches to infinity, what will happen? Let's see. So we can see in this equation that capital per household at time s, k into s over h, is equal to the discounted price of wages minus consumption per household, labor supplied. So if we multiply this equation by e raised to power rs, we can then have this equation which says limit s approaches to infinity, e raised to power r s into k at time s over h. Because if you see the equation star, this is equation star, this is actually equals to all this part of the equation on the right side of e raised to power rs. So we can simply replace this part of the equation with k at time s divided by h. So we have this equation that says when time is s, which is actually some time that approaches to infinity, so much later in this time, the e raised to power rs into k at time s over h must be greater than or equal to 0. What does this equation means? This simply says that the present value of the household asset holding at time s, something infinity later than now should be non-negative. So this equation says that later, infinitely later, the household at that time, they own assets, and the current price, the current value of those assets should be non-negative. It means they will have some value which is their discounted present value should be non-negative. So what does this equation tells us? That when the limit s approaches to infinity, at that time the capital assets holding of household is greater than 0. This is something we call non-Ponzi game condition. So what is a Ponzi game? In a Ponzi game, the lifetime consumption is greater than the present value of the lifetime resources. So you are consuming more than you have as your wealth or income in your life. But this equation is something that is non-Ponzi. So in non-Ponzi situation, the budget constraint here, this equation is actually ruling out the Ponzi scheme. So this budget constraint make a non-Ponzi game condition. For more interesting details about the Ponzi game, you can search Google about the Madoff case, the famous fraud case in America. So now let's talk about the household maximization problem. What household in the economy want to do is they want to maximize their lifetime utility subject to the budget constraint they are facing. In the Solow model, we work with variables in per unit of effective labor because it is easy to operate with normalized variables, that is, we use the comparable units. So our normalized or per unit of effective labor based budget constraint will look like this. The left part, this one, is the total discounted consumption per unit of effective labor. So this is the same thing but in terms of effective labor. So we added a in this, and this is something capital holding at time t, capital per unit of effective labor. So we added a here. Let's talk about how the household behave. To maximize the lifetime utility, household has to choose a path for consumption at each time, that is CT. So all the consumptions in the different times will be in this form. So we can set a Lagrange that will look like this, and this beta is actually a at time 0 raised to power 1 minus theta into L at time 0 divided by h. So this is effective labor at time 0. So then this is the integration time 0 starting from 0 to infinity, and this is the discounted value of the consumption and that the household will conduct to maximize its utility, and then lambda starting this constraint, and the constraint has two parts, the wages and wages plus the initial capital being subtracted by the consumption. So this is the discounted value of consumption, and the household chooses C at each point of time. Thus the first order condition for an individual is the derivative of this lambda, this Lagrange with respect to consumption. So the derivative will look like this, and we take this equals to 0, and then we rearrange taking logs on the both sides, and the log of E is 1 using RT is equal to, which we derived earlier, that the rate of return is the function of time. So we take log and then put RT, and then we differentiate with respect to time. So we get this, and we use the identity that the derivative of nature log of Ct with respect to t is the growth rate of consumption, that is C dot by C, and that is equal to RT minus rho minus theta g by theta, which is actually because this beta is equal to rho minus n minus 1 minus theta g. So we have assumed it, while C dot by C is RT minus rho or theta. This can be interpreted as, if the real returns are more than discounted rate of future consumption by household, consumption will increase. Capital C is consumption per worker, small c is the consumption per unit of effective labor.